and welcome to Pale Blue Pod, the weekly astronomy podcast that helps you feel closer to space. I am just one of your hosts. My name is Dr. Moiya McTier. I'm an astronomer and a folklorist, and I'm joined by
Corinne Caputo, a writer and comedian, and all around happy to be here kind of person.
Lovely. And Corinne, where are we recording from today?
Today we are in my reading room, which is really just like the attic with warm blankets, and it has like a window that overlooks like a cool tree, but the wind still comes in, and it's in fall. It's the only room you want to be in.
Yeah, it's the perfect temperature. We can still see the outside and the gorgeous colors on the trees. Yeah, this is a nice, cozy spot.
Yeah. And that's the only place I want to learn about something big and scary. This is a Halloween podcast.
Ooh. My mission is to help you feel less scared of big, spacey things. So hopefully by the end of this episode, you won't be as scared of today's topic, which is galaxies.
Yay!
Yay!
Galaxies!
That's a really big topic to cover in just one episode. So more specifically, we are covering my favorite galaxies and what galaxies are made of. How do we know that we're in a galaxy in the first place? And once we learned that, how did astronomers start classifying these galaxies?
Yeah, how do we know we're anything, you know?
I mean, honestly, most days I wake up and I'm like, how can I trust anything that I see or hear or sense or know at all? Like, how do I know that anything is real?
That's when you just have to say, I don't want to know. That's when you turn your back on the question and you say, it might be better to not know.
Yeah. Honestly, sometimes you have to ignore the question of like, where are we or how did we get here? And you just have to go forward with your perception. Like, it doesn't matter how I got here. I'm here now. What do I see?
What do I want to do?
That's kind of how I feel about space. Like, there's so much that we don't understand about the origins or the advanced physical laws underpinning our entire reality.
Oh my
God.
God.
There's a lot that we do know.
Yeah.
And I think that especially for people who maybe get intimidated by the vastness of space, by the scales of things, if you can find it in yourself to take a breath and to rein in that overwhelmed feeling and just start from what you can see in front of you now.
Yeah.
I think that might help some people.
Yeah. When I think about how big space is and all the answers we don't have, I'm just like, thank God I'm not in charge. Thank God it is not on me to figure it out.
Yeah, that's why I left research. I was like, I am not responsible enough to be adding.
I can't be responsible for this.
Yeah, adding to the collective knowledge of humanity. Like, I'm not prepared. Let me just build fun worlds on my own.
Yeah.
So I understand this impulse to be very anxious.
Yeah. I mean, galaxy specific. Well, I can start off by saying I was on the beach in Maine one summer night and I saw like part of the Milky Way, which blew my mind. I like did not know you could see it with a human eye. I think I'd only seen pictures in, like textbooks or online, things like that.
Right. Artists' ideas. Those aren't like photos.
Yes, exactly. And they're like colored and I had no idea you could see it on like a really clear night in a place with no light pollution. Like I grew up in New York City, so it was like, I'm not here to see stars. Like,
right. You can see like maybe 5.
Yeah, exactly. If we're lucky, we can see the moon on a good night. So yeah, the first time I saw it, it was like shocking to me. It totally blew my mind. I felt so tiny and not like insignificant, but just like totally, I was like relieved of so much anxiety. Where I was like, oh, actually, I don't need to sweat the small stuff.
I love that for you.
It did help me a lot. I mean, it didn't last. The anxiety came right back in the morning. But that night on the beach.
For that brief moment of reprieve.
I was my best self that night. Yeah.
Yeah, I understand that urge to feel very small and like scared of that smallness when you are confronted with the size of space for the first time. I noticed the Milky Way and saw it in most of its glory for the first time a few years ago in Chile. I was on top of a mountain on an observatory trip, touring different telescopes and observatories around Chile. And we were in this super dark spot. And when everyone turned off their lights at like 2 a.m, we were all standing outside, and I saw my shadow cast by the light of the Milky Way.
Whoa!
That's how dark it was. Yeah, it was like a very surreal moment almost of realizing that these photons, these particles of light from stars like thousands of light years away, yeah, they're traveling this vast distance through space only to be stopped from hitting the ground by my stupid little human body. Like, what?
That's so great.
Yeah.
I did not think that was possible.
Mm-hmm. Yeah, just
Wow.
I'm thinking of the different ways that we interact with space already all the time, I think is helpful when you're trying to get to know space.
Yeah. Yeah. I think, again, it's like you don't feel bad. You just kind of feel part of it. Like, oh, I think what I was feeling was like my ego coming up against the scale of the universe, where you're like, oh, wait, we're not important in that very kind of dictionary definition of important. It was great.
Good. Yes, I love that feeling. So galaxies can give us that feeling. Seeing the Milky Way can give us that feeling. Although I will say that, like, you see the Milky Way every day.
Yeah.
If you go outside and you see a mountain, if you go outside and you feel the warmth of the sun on your skin, if you go outside and you smell the salty brine of an ocean, all of that shit is the Milky Way. Like, you are observing the Milky Way all the time. But to have that visceral experience of seeing the stars in the night sky, super valuable.
Yeah.
But yeah, how do we know what that stuff is?
Yeah, I think that's what I was so shocked by. I think I was like, oh, if you're in it, how can you be seeing it? How do you know? How do you know?
How do you know? Let's answer that question for you, Corinne.
Okay.
Yes.
I'm dying to know.
Well, first, I think we should talk about what galaxies are made of. Like, now that we know we're in a galaxy and that there are a bunch of others out there, what do we know about them? What is the definition of a galaxy? I'm
realizing that I don't know. My brain is going to the definition of like a solar system. So I want to say it's like that, but scaled up.
What does that mean to you? If someone was like, what's a galaxy?
Yeah, is there some kind of center thing? Is there some kind of something in the center that we're like dancing around?
Maybe.
A galaxy is like a series of solar systems?
Yeah.
Ooh.
Yeah, pretty much. Okay, so you are very close. A galaxy is a collection of stars, which themselves can be the centers of their own stellar systems. But in galaxies, you also have a lot of gas. That gas can get turned into stars. You have a lot of dust left over from various interactions and events throughout the history of space. And very importantly, but very invisibly, we have dark matter. Dark matter is, actually, we don't know what it is. We have observed it out in space. We can see the effect it has on stuff in and around it. But the cool thing about dark matter is that it does not interact with light. Light just does not care about dark matter. They don't realize that each other exist. So you can't see dark matter. You can only study how it interacts gravitationally with other things.
That's so cool and weird.
Yeah, and dark matter is 80% of all of the matter in the universe, we think. So it makes up most of the matter, most of the stuff that has gravity, but we don't know what it is. And it's kind of embarrassing.
Oh my God. But it's not like, is it something that you can touch?
Yeah, because it does interact with gravity. It has like a physical form. If you had a giant hand, you could go out there and feel dark matter, but you cannot see it.
That is so weird.
And that's the definition of a galaxy. It's a very loosey-goosey definition.
Yeah.
It's all of this stuff bound together by gravity, which is confusing to us humans who love categorizing things and love putting stuff in boxes, because a galaxy can come in a lot of different forms. Because you can have collections of gas, dust, dark matter, and stars in different shapes and in different like distributions of stuff. So we've seen a bunch of different types of galaxies, and that's very exciting. How recently do you think, Corinne, that we learned we are one galaxy among many?
Oh, good question. I would say probably as long as we've had the Hubble telescope, maybe?
The Hubble telescope launched like 20 years ago in 1995.
Oh my God. In my head, that launched when my great-great-grandfather was a baby boy.
Your great-great-grandfather who, from the previous episode, knew nothing about Neptune?
Yep. He never met Neptune, but he saw the telescope.
But he knew we were in a galaxy, yeah.
I would say 200 years.
Your first instinct was better. It's basically exactly 100 years.
Really?
Yes. So this was a topic of great debate in the early 1900s. So great that the National Academy of Sciences in April of 1920 invited 2 astronomers to participate in what they called the Great Debate. This debate was between Harlow Shapley and Heber Curtis. Harlow Shapley believed that the universe was all one big galaxy, that the Milky Way was huge, that the sun was not at the center of it, and that there wasn't anything outside the Milky Way. Heber Curtis, on the other hand, believed that there were many quote-unquote island universes, and that the Milky Way was just one of them. But he believed that the Milky Way was pretty small and that the sun was in the center. That debate did not have a satisfying ending.
I was going to say, aren't neither of those things true?
Right. Neither of those things is true. There's like kernels of truth in each of them. And if you combine their hypotheses, then you get at the truth. But neither one was right. So they left that debate not knowing the answer. And then 3 years later, this young astronomer, Edwin Hubble, started looking at a specific type of star called a Cepheid variable star in the Andromeda Nebula. That's what they called it back then, to measure distances to that nebula. And Hubble realized that the most distant Cepheid variable stars in the Milky Way were much closer to us than the Cepheid variable stars in the Andromeda Nebula. So he realized that there's stuff outside the Milky Way. So there must be other Milky Way type things, other galaxies, other island universes.
Mm-hmm. I love the term island universe.
Me too.
And it feels like that, I think, in photos too, or like when you think of space, like in like a 3D concept, which is like blew my mind when I first grasped that as like a kid. Mm-hmm. It does feel like islands floating in like this. I guess they're floating in dark matter.
Yes, that brings me to a very important point. I talked about what galaxies are made of, but didn't talk about like the shapes of them because there are so many different shapes. Almost every galaxy that we have found has like the bright stuff, like the stars and the gas and the dust, the stuff that interacts with light. And then surrounding that is a big dark matter halo. So yeah, we do think that galaxies float in these clouds of dark matter.
Wow.
But that is different than like the cosmic voids in between huge galaxy clusters. They're just floating through the void of space, which is different than floating through dark matter.
Wow. Spooky.
But
in a cozy way.
Agreed. Yeah, I mean, there is something very cozy about having your own space to yourself and like getting to move around and interact with other island universes, but still having your own space.
Yeah. Everyone needs that. Everyone needs a large apartment or a house. I guess I'm not living in a brain where we're going to be in a house. And you just need to stretch out, get your own room.
Yeah, exactly. And some galaxies are more isolated than others. Most galaxies exist in little local clusters of galaxies that we call galaxy clusters. And then those clusters can actually gather into superclusters. And if you zoom out even further and you start to see the really large scale structure of the universe, all of these clusters and superclusters gather together in long filaments, in long strings that look kind of like a web when you zoom out. So we talk about the cosmic web with these these filaments of matter of all the galaxies collecting in these strings. And then in between those strings are huge voids of basically nothing.
Whoa. Nothing is so weird to imagine.
Yeah.
Wait, so when they are like kind of near each other, what's happening in that moment?
Great question. Galaxies merge and interact like all the time, especially in dense clusters of galaxies.
Yeah.
You'll see galaxies merging. Our own Milky Way galaxy has in the past merged with other smaller galaxies. They like eat each other, basically. They absorb each other's gas and dust. Their black holes will collide and grow with each other. But in about 5 billion years, the Milky Way will have its first major merger with another galaxy.
Who's merging? It's like Viacom and...
No, there's no antitrust laws out in space telling big galaxies that they can or cannot merge together. No, in 5 billion years, the Milky Way and Andromeda will merge together. These are two spiral galaxies, and I'll talk in a bit about what a spiral means, but they will eventually merge together. All of their gas will swirl together, creating this cascade of new star formation. The stars themselves probably won't collide because everything is so spread apart in space,
right.
But you'll still get a lot new stars, and the orbits of things will get jumbled so that instead of orbiting in a nice circular pattern through the spiral disk, it becomes a chaotic spherical jumble of stars moving in any direction they want.
Well, that's chaos. That's not the place I'm going to go.
We will be long dead by then.
Yeah.
Our sun actually will not survive that long in its current state.
I heard our son as an S-O-N. I'm like, our son.
Corinne and we have a son together.
We have a son together, and he will live to see that.
We have a little son. His name's Michael, and he's going to live to see Andromeda and the Milky Way collide.
The same way my grandfather saw.
Simultaneously did not know about Neptune, but absolutely knew about island universes.
That's just how men work.
Simultaneously, like, knowing things they shouldn't, but also not knowing things they definitely should.
A different plane of existence entirely.
Oh, what it must be like to be a man.
What it must be like.
I wonder that, like, at least once a week.
We solved it. Well, we figured it out. And boy, am I wondering that a lot. But now I get it. They must be very confused. All
the time. Like, not knowing what they do and don't know, it's got to be a confusing time.
Couldn't make me do it.
I would take money to be a man.
I would publish a book under a man's name and see if it does any different, is what I would try.
Well, I just published a book. That can be my control. And then the next time I'll publish under a dude's name.
Yeah, you have to do a variable next.
This is science.
Just M. McTier.
Ooh, yeah, no one will trace that back to me.
Same author photo, just with a mustache.
I'd bet I look hot with a mustache. A nice handlebar.
I'm sure you do. I've put on like the TikTok filter of like the beard and the mustache, and I'm like, that's a hot person.
Oh yeah. When I use that filter and it's like the one with tattoos and scars, I'm like, damn.
Oh my God, I love the neck tattoos. I'm like, wow, I should get that.
I was like, I didn't think I was my type, but with this filter, I am my type.
We are all our own types in the end.
Speaking of types, would you like to know my favorite galaxies?
Yes.
When I say favorite galaxies, really, I mean, would you like to know the collection of 5 galaxies that I found easily on the interwebs that also I thought effectively demonstrated the various types of galaxies that are possible?
Yes, that is what favorite usually means. When I was a kid, the word favorite had so much pressure. It was like, what's your favorite color? What's your favorite food? I feel like that was always the questions you were getting in like elementary school like projects. And it was like, I have to pick one and I have to commit to this for the rest of my life.
Lots of pressure. What did you decide? What did you do?
Well, I remember my favorite word was love. Not because I felt obsessed with that word, but just because I was like, well, that's probably an evergreen pick. Like, that'll always be a word we'll be using, I imagine.
I love the strategy here.
Yeah, there was a lot of creative strategy behind picking favorites.
Mm-hmm. That scene in Monty Python and the Holy Grail gave me a similar anxiety where I was, for a brief moment in my life, terrified that if I was asked what my favorite color was and I gave the wrong answer, like I don't know what the wrong answer would be, but if I gave it, something bad would happen.
Oh, yeah.
So you have to know.
Oh, I know that fear so specifically well. That is, I think that I would still have that overcome me if someone asked today, just when you're grown up, nobody cares. Nobody's asking what your favorite color is anymore.
No. My favorite color is forest green, for the record.
That's my favorite color to wear.
Ooh.
It's definitely my favorite color to wear. My favorite color, right now I'm into like a really like royal blue.
Respect. I don't remember what the actual word was, what the actual phrase was, but favorite. My favorite galaxies are number one, we have the Tadpole Galaxy.
Aww.
Yeah, picked in part because of its name. When I grew up, I had a little pond by my house, and I loved when the tadpoles would hatch every year, and I could see them swimming around with their little tails. So that's part of why I love this galaxy, but not the entire reason. So the Tadpole Galaxy is a barred spiral. It has a big bar across its center, and then the spiral arms come out from the ends of that bar. It's about 420 million light years away from us.
Whoa, that sounds extremely far away. It really does look like a tadpole.
Right? Yeah, we have a lot of these galaxies that are named after what astronomers just think they look like. So it does, if you look up pictures, really look like a tadpole with a head, and then its long tail that gives the galaxy its name is a stream of stars that extends like 280,000 light years. So it's pretty long. And it's thought to be left over from a merger with another galaxy, a much smaller galaxy, about 100 million years ago.
Wow.
Eventually, that tail will disappear, just like the tail on a tadpole. As the galaxy continues to rotate, stars will get pushed ahead or pulled behind. Eventually, that stream will break up and not be visible to us anymore. But that's going to take many thousands of years to happen. That is the Tadpole Galaxy.
Oh, it's so cute. I love it.
With its little bright star-forming regions, you can see the bright spots in it if you look at the pictures. That's number one. This isn't in any sort of ranked order, by the way.
Okay.
Yeah, so that's...
I'll rank them.
Yes, exactly.
I'll put them in order when you're all done.
Right. So in no particular order, Tadpole goes first. And then we have the Whirlpool Galaxy, also called M51. Now, a lot of galaxies will have multiple names. They'll have the nickname, the common name that astronomers give it, like Whirlpool Galaxy. And then they'll also have different names based on catalogs that the galaxies are in.
Okay.
So M51 means that this is the 51st object in the Messier catalog of space objects. It was created by this guy named Charles Messier, who was a French astronomer who was going around looking at nebula, these fuzzy patches in the sky, and just making a catalog of them. And eventually some of those nebulae turned out to be galaxies that we studied in further missions. So M51, it also probably has other names out there based on other missions that have observed it, but it's a grand design spiral, which just means that it's like a beautiful kind of platonic ideal of a spiral.
It is extremely gorgeous. Yeah. I'm looking at it because I was going to say, there are other galaxies with a shape like this. So I feel like Whirlpool is it's hard to claim that.
Right.
Because there's going to be multiple, but this one seems like it really is the peak version of itself.
I know. It's like you ask a Renaissance painter to imagine a spiral galaxy, and it gives you that, like, perfectly symmetrical. The colors are nice. It's a beautiful spiral galaxy about 30 million light years away, so much closer to us than the Tadpole Galaxy. It is interacting with another galaxy that you can see at the end of its tail.
I'm seeing that here,
Yeah, that other galaxy is called NGC 5195. And we use the Whirlpool galaxy because it has such a perfect spiral structure to understand more about the structure of galaxies and how it forms and how it can change or be maintained over time.
Cool.
Now, next up, we have the Sombrero Galaxy.
Oh, I had no idea there was one called that.
Yes!
I'm dying to see a picture of this one. Okay.
Mm-hmm.
I kind of see it.
Yeah, you kind of see it. It's not...
This one is crazy looking to me.
Okay, so this is a peculiar galaxy. Like, that's its actual classification. It also is about 30 million light years away and is 50,000 light years across.
This looks like a portal. Like, this is absolutely some kind of hole to something else.
Uh-huh. Yeah, it's weird looking. Like, we saw that and astronomers were like, what is going on there? This is not how we expect galaxies to look at all.
Is this just like the angle we're seeing it at? Is that what's going on?
That's part of it. So the Sombrero Galaxy is what we call edge-on. There's edge-on galaxies and there's face-on galaxies. Face-on galaxies are a lot easier to study because you can see all of it at once. Edge-on means that it's a lot harder to study because we can only see, like, the edge of it. We can't see its face. So for those of you who aren't actively right now looking at pictures of the Sombrero Galaxy, it's called that because it has this big, bright nucleus in the center that's kind of like a spherical bulge. And then surrounding that is a disk that doesn't, we think, have spiral arms, but it has this huge dust lane, this big, like, dark, dusty patch that surrounds the entire galaxy. And that's where a lot of its molecular gas is. That's where a lot of the galaxy's cold hydrogen gas lives. So a lot of cold gas in this dust lane on the edge of the Sombrero Galaxy.
I'm on the NASA's like page for it, the image, and like the image is such a large image that like you get the magnifying glass, and I just got scared when it zoomed in. I was like, "Whoa, it's so big!"
It's so big. Yeah, this is a galaxy. You have a picture, an actual picture of a galaxy on your computer right now.
This is freaking me out.
So that is the Sombrero Galaxy. Next, I had to rep the ellipticals. I can't do a list of galaxies without naming Cygnus A. This is one of the most well-studied elliptical galaxies in the universe. It's about 600 million light years away. It has really bright emission in the radio part of the electromagnetic spectrum. So when you look at this galaxy in the visual range, like in the light wavelengths that we can see, it probably doesn't look that spectacular. But if you look in the radio wavelengths, it gets super bright. It's actually the second brightest radio source in the entire sky, even though it's so far away. It has a supermassive black hole at its center that is 1 billion times more massive than our sun, making it like 2,000 times more massive than the black hole at the center of our galaxy. And if you look at this galaxy in the radio, you can see these big bubbles. These are jets coming out of the black hole at its center that clear out a lot of the gas and dust.
That's what I was going to say. The pictures I'm looking up, it's like nothing. It's almost like a barbell or like a hand weight where it has these like heavy sides and nothing in the middle.
Yeah, and those bubbles extend out beyond like where the stars stop in this galaxy. So they're really, really big. Cygnus A is the galaxy that the aliens from the book and movie Contact are from.
That's really funny.
So that's Cygnus A repping the elliptical galaxies. And then we have our little homie NGC 1052-DF2.
Easy to say, easy to remember. I love it.
This is an ultra diffuse galaxy. So it's the stars in it are very spread apart compared to other galaxies that we've studied. It's 60 million light years away, has less than 1% the number of stars that the Milky Way has. So it's quite tiny. But the really interesting thing about this galaxy, think back to when I told you what a galaxy has to have. Stars, gas, dust, dark matter. This galaxy has like less than 1/400th of the amount of dark matter it should have.
Why? That's scary. Where'd it go?
That's a great question. So we haven't been able to observe this directly with data, but based on some simulations, we think that the dark matter can get stripped away when different galaxies are interacting with each other.
Oh.
But we have since found a couple other examples of these dark matterless galaxies, but DF2 is the first one that we found just a couple years ago, and it rocked the astronomy community.
Yeah.
People were so confused.
I'm sure. This is so, okay, how do we know that it is a galaxy if these stars are so kind of far apart? Like, I know it was like kind of a flexible definition this morning, 5 minutes ago when you said it. But what made us realize that this one was a galaxy?
That's a great question. It's its own island of gravitationally bound stuff. So we can see the stars like orbiting around that galaxy's body. So we know that they are all bound to each other.
That makes sense. Mm-hmm. I'm seeing a YouTube video called The Galaxy with No Dark Matter.
Mm-hmm. It made a lot of headlines.
Yeah, that's really kind of spooky to me now that I just got on board with dark matter, and now you're telling me. Now you're telling me it's gone?
Now, I mean, it's the exception that proves the rule.
Yeah, you're right. You're right. I learned that from He's Just Not That Into You. And that movie really taught me about exceptions and rules.
Oh, yes, the educational tome of our time. So what do you think of these galaxies? Yeah.
Okay, I am going to rank them. Here's my overall vibe I'm getting from each one. Tadpole, obviously the cutest one.
Mm-hmm.
Cute, appropriately
named.
No
argument there.
No argument. We love it. It's a top contender. Whirlpool is almost so beautiful that it's like untouchable, like a little too cool, you know, but like an influencer type galaxy.
Oh, yeah.
The Sombrero galaxy scared me. That one was scary when I clicked on the picture, and there's no reason it should have scared me. I'm just a scared person, but I still have to knock it for that.
That's fair.
Cygnus A. That one was hard to see, and I do think it has aliens now. So we have to think that Contact was based on facts.
Right.
And NGC 1052 DF2. It's kind of spooky, that one. That one is ripe for a Contact type movie, I think.
Because it doesn't have dark matter?
Some kind of horror movie that takes place out there where it's like, we got to find out where the dark matter went. And then they go out there and then it's like some monster is hiding behind a star or something.
Yeah. I love that you went there because I feel like the name that we have given dark matter is definitely a misnomer. I'm a big fan of Dr. Chanda Prescott-Weinstein, who would prefer to call it like transparent matter or like clear matter, because it's not that it's dark. It's not the absence of light. It's just the lack of interaction with light.
Yeah.
So we have given it this name that makes it feel very dark and spooky and mysterious. And I know a lot of people who get scared by dark matter, but I love that we have that association between dark matter and scariness. But then I showed you a dark matterless galaxy and you're like, nah, it's scary.
No. Yeah, that is actually scarier when there is no dark matter. You're so right. Clear matter, not scary at all. That reminds me of like, you know, the 90s kind of books that were clear with the glitter and the liquid in it, and you could like push it around.
Gel pens. Clear matter is gel pens.
Exactly. Clear matter is fun, cool, cute. Love that. So in that case, well, I think the ranking is the ranking you read them in. I think it goes. This is extremely creative of me. Number 1. Okay, let's start at number 5. We'll count down to reveal. Number 5 is NGC 1052 DF2 because kind of a little underwhelming, hard to see. No dark matter is very creepy. I don't want to look too hard into that. Someone else is in charge of that. Cygnus A, okay, interesting shape. I like that it's hard to get one of those like artsy style NASA pictures of it, that it's like these kind of radio wave colored images. I think that's fun.
Yeah, it's a rebel. It refuses to have its picture taken by NASA.
Exactly. And I like that because I don't always want to get my photo taken. Sombrero Galaxy, very cool. Very cool. Actually, you know what? It's going to go NGC, Cygnus A, then Whirlpool, then Sombrero, then Tadpole as number 1.
Because it's the cutest and the most
Because
aptly
it's the
named.
cutest. And it's also, to me, the one that would be most welcoming to me if I were to visit. This is about me in the end.
Yeah.
It's about me and making little trips out to all of these galaxies. And which one do I think would be good to talk to? And I do think it would be Tadpole.
Mm-hmm. Although by the time you get there, because it's 420 million years away, it would be a frog galaxy by then.
I'll have nothing to talk about. It will be a frog galaxy by then. You're right. And I don't care about frogs the way I like tadpoles, so.
Oh, interesting. I would love to meet a frog galaxy. just ribbiting and hopping around the universe.
There's like fully a frog shaped. You can clearly see the legs and like
Yes. And so, like I'm done with spiral arms. I'm over them. I want to see frog legs on galaxies.
Where are the frog legs?
That is the question of the century. You know what? 100 years ago, we didn't know we were in a galaxy. We didn't know that there were others out there. Maybe 100 years from now, we'll find a frog galaxy.
We need to zoom out far. The thing is, we're not zooming out far enough. It's probably what it is. Maybe all of these galaxies together, if you're looking at the universe from a god-type character's perspective, it's just one large frog.
Everything is a frog.
Uh-huh.
Oh, I love that. Okay, so we have ranked these galaxies.
The definitive ranking of them.
Yeah, and obviously this little subsection, this little slice of galaxies is representative of all of them. So you ranking these 5 is also you ranking all of the galaxies that exist.
Oh,
all
absolutely.
Hundreds of billions of them.
That's completely right. And also, if anyone out there listening has a question and wants to know where I would rank another galaxy that you might be familiar with, let me know. I can easily pop that into this definitive chart.
Yeah, we can have throughout the pod, just a running ranking.
You need to know this is a living ranking. It's a living document. It's a living ranking. It's going to be changing all the time. So you're going to have to check back.
Don't hold us to anything we say. Expect it to change.
Yeah, just like Pluto's not a planet anymore, science changes all the time.
That means it's working.
Exactly. And that means science is working.
So we have ranked these galaxies, and we will continue to have a running, living document of Corinne's galaxy rankings. But ranking galaxies is different from classifying them, from putting them into different categorical boxes. So I wanted to tell you a bit about how astronomers classify galaxies.
Yes.
And actually, this is not a very satisfying lesson because there is no single way that astronomers classify galaxies. You might hear some astronomers classify galaxies according to their size. So we would call the Milky Way is a galaxy, but the large and small Magellanic Clouds are dwarf galaxies, so named because they are just physically smaller. They have fewer stars than a bigger galaxy. But there is no set cutoff. There's no threshold in the number of stars or in size or in mass. It's just a subjective thing. People can say that galaxy is a dwarf, but that galaxy is full grown.
I'm hearing a lot of like these astronomers not really all defining something super specifically, or they are, when they do define it specifically, other people are like, no.
Yeah, we can't catch a break. There is no right amount of categorization. But this is what happens when humans, as they're trying to understand the world around them, create classification schemes as they learn more stuff, right? Because as you're learning, you're going to encounter something that doesn't fit neatly into the scheme you've already made, and humans are stubborn, so we often don't want to adjust our classification scheme, and we just add another category, and it gets messy.
I get it.
I have a lot of feelings about how humans tend to classify things and then just it's wrong. In all sciences, in biology, in chemistry, like we're so hell-bent on classifying stuff, but so bad at doing it.
That's so funny. I feel like that's true even in like, I do that in my personal life where I'm like, I need to define this. I'm this kind of person, or like I'm doing this and I'm not. I'm really not.
Yeah. All those social media posts that you see, like, there are 2 types of people.
Oh my God, yes.
No.
No.
No, there's more than 2 types of people. But there are only 2 types of galaxies, and it's dwarf galaxies and not dwarf galaxies. So you might see astronomers classifying galaxies by their size. You might also see them classifying galaxies by a combination of their brightness, their color, and the wavelength that we observe them in. So the Cygnus A galaxy, for example, is a radio loud galaxy. We describe it based on the wavelength where most of its energy is emitting. We sometimes would call some galaxies an ultraluminous infrared galaxy, a ULIRG, ULIRG. And that is classifying based on its brightness, based on its wavelength, ultraluminous and infrared. We also sometimes refer to galaxies as blue versus red. A blue galaxy is very young with lots of newly formed stars that are shining blue and very bright and hot and energetic. A red galaxy would be something with older stars that aren't actively forming and they're less energetic, they're cooler, they shine in the red part of the spectrum.
I would never think of red as cooler.
Another way that astronomers differ from non-astronomers. Yeah, it's actually a constant struggle when I'm doing my science communication and I'm trying to show temperature of something. Do I make blue hot or cold? Because to my astronomer brain, blue is hot. Blue is very energetic. But to my normal human brain, blue means cold. So it's a constant struggle.
That is wild. Good luck with that, Moiya.
Thank you.
Again, I'm glad I'm not in charge.
Thank you. I appreciate that. The most common way to classify galaxies, to separate them into groups, is by their shape. Edwin Hubble, the same guy who basically confirmed that there are other galaxies out there, and then also confirmed the accelerating expansion of the universe, he looked at a bunch of different galaxies through his telescope. Not the Hubble telescope. That was created and launched after he died. But he had his own telescope that he looked through to see galaxies and make notes on their shape. Like, what did they just physically look like? We call this galaxy morphology. And so in 1926, Hubble came up with this classification scheme called the Hubble tuning fork, where he separated galaxies into two broad groups. On one side, you have the spiral galaxies that have a flat disk with that gorgeous spiral shape perfectly demonstrated by the Whirlpool galaxy. On the other side of this tuning fork, you have elliptical galaxies. They're spherical, they're more chaotic, the stars are moving in any direction, and they don't have a defined disk or spiral shape. At the time, they had this notion that galaxies evolve from ellipticals into spirals, that they develop their spiral structure over time. We now know that it's the complete opposite, that spiral galaxies form and then they merge, and through the chaos of their collision, they create an elliptical galaxy. So when the Milky Way and Andromeda collide, we will be an elliptical galaxy after their merger. But still, Hubble, not knowing what we know now, called the ellipticals early type galaxies and the spirals late type galaxies. And this is a convention that we still use today, even though we know it's wrong.
Really? Oh my gosh. That's really wild.
So astronomers will literally call a spiral galaxy a late type galaxy, knowing that it's actually pretty young and will eventually turn into an elliptical.
That's really funny.
It's really frustrating.
And in their heads, are they constantly just redefining it in their head?
That's what I do.
Yeah.
I translate it in my head. I'm like, oh, okay, late type galaxy. They mean a spiral. They mean
yeah.
That means it's young. That means it's forming stars. It's blue.
That's so funny.
Yeah, that is just one way that astronomers use old jargon or old classification schemes, even though it doesn't match our current understanding of the universe. There's a constant translation going on in conversations about galaxies.
That is so ripe for errors to me. I'm like, wow, we're really opening the door wide for miscommunication.
Yes. I cannot agree with you more. The biggest differences between spiral and elliptical galaxies are their age and color. Spiral galaxies are younger and bluer than ellipticals, which tend to be older and redder, again, because they form through the collision of young spirals. But also there's this fun difference in how their structure is maintained. A spiral galaxy has a flat disk with the spiral arms in the disk, and the stars are moving in circles around that disk. The shape of a spiral galaxy is maintained by the circular orbits, by the rotational motion of these stars around the galaxy. An elliptical galaxy doesn't have those neat circular orbits. I told you that it's just chaos and the stars are moving in any direction. That creates what astronomers call pressure. It's not pressure in like the way that someone pushing on your body is pressure, but the chaotic motion, the fact that these stars aren't moving in one direction but are moving in all directions together, that creates a pressure-dominated structure. So these elliptical galaxies are essentially held together by the random chaotic motion of their stars.
Whoa. Well, that's how I function. I'm really flying by the seat of my random acts, my random little hobbies. I'm starting and stopping.
Yes. You know what? That's a great point. If you feel a little chaotic in your life, if you feel like you're just bouncing from one thing to another,
you can be a gorgeous galaxy.
Hell yeah. You're a gorgeous elliptical. You are maintaining your structure through pressure. And that is just as valid as maintaining your life structure through order and control like a spiral galaxy does.
Absolutely. Wow, we really cracked the code on that.
We did. That's all I have to say about galaxies and their shapes.
I mean, they're really stunning. This is going to sound weird, but they are iconically space. They are like...
Facts, yeah.
When you're thinking of space, it's like some beautiful picture of a galaxy.
Mm-hmm. Listeners, I want to know what your favorite galaxy is.
Yes.
I want to see a picture. Please tag us.
Yeah.
We're at Pale Blue Pod. We want to see your favorite galaxies. We didn't say this in the last episode, so let's say it now. Now that people have listened to us for 2 episodes and they've obviously fallen in love with our charm and our wit.
I know. I can hear them now. Cheering for us.
Cheering for us and our chaotically stabilized structures.
That's all we are.
Corinne, where can people find you on the internet?
I love that question. I am Corintellectual, which is just the word intellectual with a C-O-R at the beginning, on Instagram, Twitter. And that's where I am. I'm not hanging out in the other spots. I'm just a lurker on TikTok. So.
Yes, I'm mostly lurk there these days as well. You can find me on those platforms, Twitter, Instagram, lurking on TikTok at GoAstroMo. So please follow us. Please follow Pale Blue Pod, and we will be back next week with another episode. Corinne, you want to tell them what we're talking about next week?
Gosh, it's going to be space.
Yeah.
I don't have the notes in front of me.
No, that's okay. I think that maybe that's all the hint they get. Next week, we'll be talking about space.
It's an Easter egg. See if you can narrow that down.
We'll be talking about the origins of space.
Oh, right. Yes.
Next week. So join us back for another episode. It's about time for us to leave Corinne's reading room. I'm getting a little hungry.
It's true, but I do think we can see the stars right now. I think we could go see the tail of the Milky Way if we try.
Let's leave this reading room and go see if we can find our shadows cast by the Milky Way.
Yes. Okay, everyone, keep it spacey.
Yeah, keep it spacey.
Keep it spacey.
Pale Blue Pod was created by Moiya McTier and Corinne Caputo with help from the Multitude Productions team. Our theme music is by Evan Johnston, and our cover art is by Shay McMullen. Our audio editing is handled by the incomparable Misha Stanton.
Stay in touch with us and the universe by following @PaleBluePod on Twitter and Instagram, or check out our website, palebluepod.com. We're a member of Multitude, an independent podcast collective and production studio. If you like Pale Blue Pod, you will love the other shows that live on our website at multitude.productions.
If you want to support Pale Blue Pod financially, join our community over at patreon.com/palebluepod. For just about $1 per episode, you get a shout out on one of our shows and access to director's commentary for each episode. The very best way, though, to help Pale Blue Pod grow is to share it with your friends. So send this episode, this link, to one person who you think will like it, and we will appreciate you for forever.
Thanks for listening to Pale Blue Pod. You'll hear us again next week.
Bye.